My name is Russell Smith with Smith Steelworks. I would like to welcome you to our discussion today that will cover some metal finish specifications that are commonly seen in the finishing industry. Let's begin by talking about surface preparation. It is often said that the difference between a great finish and a bad finish is found in the surface preparation. Unfortunately for the consumer, the bad finishes do not show their failures for 6 months to a year. But when they do, it's ugly, it's damaging, and it will make you regret saving the few extra dollars. The great finishes manifest themselves year after year as the original coatings maintain color, prohibit rust, and ultimately protect your steel products from the elements. Everything I will be addressing today applies to outdoor environments: sun, rain, snow, temperature extremes, sprinklers, and all other elements that your outdoor steel products will encounter. In the steel industry, our surface preparation requirements are governed by the Steel Structures Painting Council, or SSPC, and the National Association of Corrosion Engineers, or NACE, which we will refer to throughout this video. First, I would like to talk about SSPC SP-2, hand tool cleaning. This process is not found in the National Association of Corrosion Engineers, or NACE, because it is not an adequate surface preparation to prevent against any kind of corrosion. Hand tool cleaning refers to surface preparation that uses non-power handheld tools to clean a steel surface. Hand tool cleaning is intended to remove all loose mill scale, rust, paint, and other contaminants that may be detrimental to a coating application. Material is considered adherent if it cannot be removed by lifting with a dull, flexible putty knife. This process is almost always completed in the fabrication stage right after the welding has taken place. Second, I would like to discuss SSPC SP-6 NACE No. 3, commercial blast cleaning. This is most commonly seen in the industries that provide outdoor site furniture, pavilions, and playground equipment. It allows for stains or shadows up to 33% of each unit area of surface to remain. This process removes up to 67% of all visible oil, grease, dust, dirt, mill scale, rust, coating, oxides, corrosion products, and other foreign matter on the surface. This process can be completed 6 times faster than the more superior specification of SSPC SP-5 NACE No. 1, white metal blast cleaning. Lastly, I would like to talk about SSPC SP-5 NACE No. 1, white metal blast cleaning. White metal blast cleaning is to be used to clean unpainted or painted steel surfaces prior to applying high-performance protective coatings or lining systems. SSPC SP-5 NACE No. 1 requires that all visible oil, grease, dust, dirt, mill scale, rust, coating, oxides, corrosion products, and any other foreign matter on the surface to be 100% removed. SSPC SP-5 does not allow for any shadows or stains to remain on the surface. As you can see, this process takes 6 times longer than the SSPC SP-6 that is most commonly found in the industry. Let's talk about how this relates to longevity and which surface preparation is best for your application. We have talked a lot about how surface preparation is used to clean the metal surface, but there is much more to surface preparation than producing a clean surface free of all contaminants, as discussed in our review of the 3 surface preparation options. Proper surface preparation also allows for a strong mechanical bond between the substrate and the high-performance protective coating. An SP-2, if viewed under a microscope, would show a relatively flat surface with foreign contaminants throughout the surface. An SP-6 would show shallow ridges and valleys with 33% foreign contaminants left on the surface, meaning your rust, your corrosion, your mill scale, it would all be left on it. An SP-5 would show deeper ridges and valleys with no foreign contaminants on the surface. These ridges and valleys increase the surface area, creating a strong mechanical bond between substrate and powder coat top coat. For example, if you have a 1 square foot metal plate and it is sandblasted to SSPC SP-5 white finish, it will create up to 2.5 times the surface area for the powder to adhere to, as shown right here. Now let's discuss the powder coating process, the chemistry, and the benefits. The super durable powder coating top coats are formulated to American Architectural Manufacturers Association Guide AAMA 2604 and AAMA 2605. The requirements for performance testing outlined in AAMA 2604 and 2605 outline the standard for color retention, chalk resistance, hardness, gloss retention, abrasion resistance, chemical resistance, and dry film thickness. The part of the AAMA 2604 and 2605 requirements that have to do with surface preparation are manifest in the salt spray humidity testing as well as the adhesion testing. For the salt spray humidity testing, the steel sample is scored down to bare metal and placed in a controlled salt spray humidity environment for a period of 4,000 to 5,000 hours or 5 to 7 months. This test measures the creepage from bare steel out into the powder surface, as well as blistering from rust forming under the surface. The adhesion test is done right after powder coating and is done by scoring the material in a crosshatch pattern, taking a high adhesive tape and pulling it off to see how much of the powder actually comes off. A couple other tests that can be performed to test the bond between the powder and the steel are the impact test outlined in ASTM D2794 and the bend test as outlined in ASTM D522. The American Society for Testing and Materials, ASTM, states, coatings attached to substrates are subjected to damaging impacts during the manufacture of articles and their use in service. In its use over many years, these test methods for impact resistance and elongation resistance that occurs when the substrates are dimensionally unstable, bent, or impacted during the manufacture of articles or when the articles are abused in service has been found to be useful in predicting the performance of organic coatings. The impact test is performed by dropping a dull-nosed weight onto a piece of powder-coated steel. After performing the test, examine the steel for chipping, cracking, or powder separation from the steel. The bend test is performed by bending a piece of steel 180 degrees back towards itself. After test is complete, examine for cracking or powder separation. In order to achieve an AAMA 2604 or 2605 standard, the process that needs to be followed is sandblasting to SSPC SP-5 NACE white metal finish, primed with the small molecule epoxy primer, and powder coated with a super durable TGIC polyester top coat. When powder coating, it is recommended to use a small molecule primer to enhance that mechanical bond between substrate and powder coat top coat. When viewed under a microscope, the molecule size of a primer versus a top coat is going to be significantly smaller. The reason for this is the top coats are formulated for sun fade resistance, chip resistance, cracking resistance, chalking resistance, chemical resistance. So there's a lot of formulation going into that to create the ultimate superior top coat finish. However, for a primer, it's got one job, and that job is to enhance the bond between the steel substrate and the powder coat top coat. When powder coating, the first step is to apply the small molecule primer electrostatically. And then bake the steel in the oven until the primer has started to melt. It is then removed from the oven, allowed to cool down, and the top coat is electrostatically applied. The part is then returned to the oven and baked until powder is fully cured. Bake times vary depending on steel thickness. Powder cannot be cured until the core temperature of the steel has reached 400 degrees and allowed to cure at that temperature for 10 minutes, or core steel temperature of 380 degrees for 13 minutes. When followed, the process of sandblasting to SSPC SP-5 NACE white metal finish, priming with a small molecule primer, and powder coating with a super durable TGIC polyester top coat, rust creepage will still occur when the finish is scored down to a bare metal. However, it occurs at a very slow rate. This rate of creepage is slowed by the distance of travel, as well as by the bond created from utilizing the small molecule primers. Blistering is also dramatically slowed because of the difficulty of water penetration and corrosion formation at the point where the substrate meets the primer. I would now like to address the question, is primer necessary for outdoor steel application? When a part is powder coated using a super durable TGIC polyester top coat and primer is not applied, it would look like this under the microscope. The rate of travel is greatly enhanced, turning a 15-year coating into a 3 to 5 year coating. Should we use primer? I will let you be the judge. Now let's go outside and look at some real-world examples. Here is a bench that underwent the sandblast to SSPC SP-5 NACE No. 1 white finish. It was epoxy primed and it was powder coated with a super durable TGIC polyester powder coat. This is the bench after 4 years of being out here in the sun, in the rain, in the snow, in the ice, in the hot and cold fluctuating temperatures. And as you can see, the powder is holding up beautifully. There is a good mechanical bond, there is no sign of rust, and the bench, the finish, the color retention, it all looks like it was just put out here yesterday. In this example, we have a bench that was sandblasted to SSPC SP-6 NACE No. 3 commercial blast cleaning. It was epoxy primed with a small molecule primer, and it was powder coated with a super durable TGIC polyester powder coat. This is after 3 years of it being in the same environment. We have rust creepage, we have powder pulling away from the laser scale, and we also have bubbling. Here we have a trash receptacle that was cleaned to an SP2 hand tool cleaning finish, and it was powder coated. As you can see from the close-ups here, at the laser scale, the powder has come off. As you can see here, the color retention is still really good. The sun fade hasn't gotten to it. The chemical resistance is still good. All the properties of a top coat are still intact, except it is not attached to the steel. The bond is broken. And on the surface, the powder has creeped really fast. Would you believe that it's only been 6 months since we did this one?